Here's an example. It's the first example of a kind of a wrinkle we might run into. So I'm going to use those same 7 steps. This is an optimization problem. We can tell because we see this word minimum. So again, they're not very subtle. If y is 2x minus 8, what is the minimum value of the product xy? So what's the thing I want to maximize or minimize? Well, I want to minimize the product. So my very next job, step 2, is to write a function that describes the product. So I'm going to call it p of x, and that's x times y. And here's my first problem. The rule says that the function I want to maximize, in this case the product, has to be a function of one variable. So is there some way that I can rewrite xy so that it only uses one variable? And here's our answer. They've actually made it pretty obvious what kind of substitution I can make. Instead of y, I'm going to plug in 2x minus 8. So here's my new function. P of x is x times 2x minus 8. Now I've completed step 2. I have the quantity I want to minimize, the product, written as a function of one variable, x. So now I need critical points for p, and I need endpoints. Doesn't look like there's any endpoints in this problem, and I'll make my table of values. So to get critical points, I need p prime of x. Ooh, probably would have been easier if I multiplied this out first. This is 2x squared minus 8x. So p prime of x is 4x minus 8. Again, this is linear, so I'm never going to have a p prime of x that's undefined. I'm going to get one critical point when I set p prime equal to 0. I'm going to get x equals 2. And now I'm ready to make my table of values. So here I go. Recall I'm trying to minimize p of x. I only found one critical point. That was when x equals 2. Does this problem have any endpoints? Was there any minimum or maximum value of x or y that's either real or implied? Well, we're never told that x or y has to be positive or can't be negative, and there's no biggest number and no smallest number, so I don't have any endpoints in this case. So I only have this one option, which is x equals 2. When I evaluate my polynomial, 2x squared minus 8x at x equals 2, I get a value of negative 8. The only other thing I might want to do is just confirm that that's not an absolute maximum, that's an absolute minimum. I could pick any other value. What happens if I plug in 0 to the p function? Well, that's going to be 0. So that makes it clear that negative 8 is the lower down value. Negative 8 is my minimum value for the product xy. So here's my next example. I have a piecewise function, f of t, that represents the rate at which someone using an exercise machine burns calories. So I have a formula, a polynomial formula for f of t on this beginning interval, and then after that f of t is just piecewise linear. So for the time interval 0 to 24, at what time is f increasing at its greatest rate? So they love to put all these words in here and just see if they can't trip you up. You have to ask yourself, what am I trying to minimize or maximize? So I think I'm trying to find the greatest rate of f's increasingness. So the rate at which f increases is called f prime. So I want to maximize f prime. All right, now that I've figured out what function I want to maximize, I need to do two things. I need to find any critical points for that function, and I need to find any endpoints for the function so that I can include them all in my table. So